Good morning. I'm Dr. Huang. Today, we're going to learn some rules for significant figures when we perform calculations. First, let's go over the rules for addition or subtraction. The rule is very simple. The answer should have the least number of decimal places as the numbers we want to add together, or we want to subtract. Let's look at some examples. 0.06 plus 1.003. First, we can use a calculator to calculate the answer. When we plug these two numbers into a calculator, we get 1.063. Then we will count how many decimal places are the two numbers. The first number has 1 and 2 decimal places. The second number has 1, 2, 3 decimal places. According to the rule, the answer should have 2 decimal places. So the final answer is 1.06. Let's look at the second example. 11.234 minus 1.1 plus 0.23. When we plug these three numbers into a calculator, we will get 10.364. Then let's count how many decimal places for each number. The first number has 1, 2, 3 decimal places. The second number has only 1 decimal place. The third number has 1, 2 decimal places. According to the rule, the final answer should only have 1 decimal place. Therefore, the final answer is approximately 10.4. Let's look at the third example. 1.23 minus 0.13. If we plug these two numbers into a calculator, we get 1.2. Then let's count how many decimal places for each number. The first number has 1, 2 decimal places. The second number has 1, 2 decimal places as well. According to the rule, the final answer should have 2 decimal places. Therefore, the final answer is 1.20, not 1.2. Then, let's look at the rules for multiplication or division. The rule is also very simple. The answer should have the least number of significant figures as the numbers we want to multiply or divide. As you may not notice, when we add or subtract numbers, the answer should have the least number of decimal places. When we multiply or divide, the answer should have the least number of significant figures. Let's look at the examples. 0.08 multiply 1.003. The first number has only 1 significant figure. The second number has 1, 2, 3, 4 significant figures. According to the rule, the final answer should have only 1 significant figure. If we plug these two numbers into a calculator, we get 0.08024. If we only have 1 significant figure, the final answer should be 0.08. Let's look at the next example. 1.234 divided by 0.617. If we plug these two numbers into a calculator, we get 2 as the answer. Then we can count how many significant figures for each number. The first number has 1, 2, 3, 4 significant figures. The second number has 1, 2, 3 significant figures. According to the rule, the final answer should have only 3 significant figures. So we should write down our final answer as 2.00. Let's look at the last example. 2.23 divided by 0.25 multiply 0.1063. The first number, 2.23, has 3 significant figures. And the second number has 1, 2 significant figures. The third number has 1, 2, 3, 4 significant figures. According to the rule, the final answer should have only 2 significant figures. If we plug these three numbers into a calculator, we get 83.91. There are more digits afterwards. But since our final answer should only have 2 significant figures, if we have a 1, 2, 3 sig figure for the intermediate result, it should be enough. According to the rule, the final answer should be 84. I recommend you to write down as 8.4 times 10 to the first power. Let's look at two more examples. For these two examples, they include multiplication, division, subtraction, and addition. Let's see how the rules work for mixed arithmetic calculations. Let's look at the first example. 30.281 times 10 to the negative 2 power multiply 6.484 divided by 1.68 minus 1.04. According to mathematics, we need to calculate this part first. And according to the rules we just learned, when we multiply or divide, the answer should have the least number of significant figures. The first number has 1, 2, 3, 4, 5 significant figures. The power term has unlimited number of significant figures. Let's look at the next number. 6.484 has 1, 2, 3, 4 significant figures. Let's look at the last number. 1.68 has 1, 2, 3 significant figures. According to the rule, the intermediate answer for this step should have 3 significant figures. Let's plug these numbers into a calculator. What we get is 1.168. There are more digits afterwards. The intermediate answer for this step is approximately equal to 1.17. We copy down minus 1.04. The first number has 1, 2 decimal places. The second number also has 1, 2 decimal places. The answer should have 2 decimal places. If we plug both numbers into a calculator, we get 0.16. Then, let's look at the second example. 1.749 minus 3.489 divided by 1.6842 plus 1.04. According to mathematics, we need to calculate 1.749 minus 3.489 first. The intermediate answer for this step should have the least number of decimal places. The first number has 1, 2, 3 decimal places, and the second number has 1, 2, 3 decimal places as well. Since both numbers has 3 decimal places, the answer for this step should have 3 decimal places. And if we plug these two numbers into a calculator, we get negative 1.0337. Oh, sorry. The answer should be negative 1.741 for this step. According to mathematics, the next calculation is negative 1.741 divided by 1.6842. According to the rules of significant figures, the answer should have the least number of significant figures. The first number has 1, 2, 3, 4 significant figures. And this number has 1, 2, 3, 4, 5 significant figures. According to the rule we just learned, the answer for this step should have 4 significant figures. The answer for this step should have 4 significant figures, and this number should be roughly equal to negative 1.034. The final step for this calculation is negative 1.034 plus 1.04. If we plug these two numbers into a calculator, we get 0.006. The rule says the final answer should have the least number of decimal places as the numbers we try to add together. This number has 1, 2, 3 decimal places. This number has 1, 2 decimal places. According to the rule we just learned, the answer should have 2 decimal places. Therefore, the final answer is 0.01.